Right, well, here we are. Next lot. Here we are on the 8th of February for you guys, the lesson. This is the second part. We're going to talk about factorizing quadratic trinomials. And if I can emphasize that this is absolutely essential that you get right. Right? You've got to work on this if you're not sure about it, be able to factorize quadratic trinomials, because this is crucial to a lot of stuff that we're going to do. So I'm going to write in a rainbow pen, important. All right? Missed the N. Important. You've got to think that this is important stuff and we're going to have to do it. All right, so let's just talk about expanding. Let me zoom in on this. As we've been talking about, if I expand this expression x plus 3, bracket x plus 2, what do we have? We'll expand each one, x squared plus 3x plus 2x plus 6. Okay, that's fine. And then I simplify, I get x squared plus 5x plus 6. Now the thing is, there's a relationship between this 3, this 2, this 5, and this 6. 3 plus 2 is equal to the 5. 3 times 2 is equal to the 6. So if I can find, if I'm going back the other way, as in factorizing, not expanding, if I can reverse this process, I need to find two numbers that multiply to the constant term and add to what we call the coefficient of x, the number before the x. So I'm going to go through a few of these to show you and illustrate how we might do that. Okay, x squared plus 4x plus 3. So I need two numbers. They have to multiply to 3 and they have to add to 4. What are those two numbers? Well, think about the factors of 3. Well, in this case, it's a straightforward one. There's only 3 and 1. 3 times 1 is 3. That's good. 3 plus 1 is equal to 4, which means that that's also true. So I can simply write this as x plus 3, x plus 1. It's as simple as that. Now, you can always re-expand using our favorite FOIL method to see whether you've got it right. And in this case, I can say confidently that we do have it right. So you're looking for two numbers that multiply to the constant term, in this case 3, and add to the coefficient of x, which in this case is 4. And the two numbers end up being 3 and 1. Right, same principle here. Now, in this case, we need to take note of the fact that we've got a negative 6x. So, and we've got a positive 8. So we've got two values. They have to multiply to 8, right? They multiply to the constant term, and they have to add to negative 6. What are those two numbers? Now, something to think about is that if my sum is negative, right, a negative number must be involved, one way or the other, when I add two things together. But if my product is positive, the only way that a negative can be involved and we get back to a positive is if it's a negative times a negative. So we're looking for two negative values. There's a clue in that. Now, what are the factors of 8? Well, it's 1, 2, 4, and 8. Well, the clue is there's 4 and 2 get us to 2 times 4 equals 8. But 2 plus 4 is equal to 6. Now, that's not correct because we're looking for negative 6. But what if I did negative 2 plus negative 4? Well, that does get me to negative 6. And what if I change it to negative 2 times negative 4? Well, that gets me to 8. So the two numbers are negative 2 and negative 4. So my quadratic trinomial goes to being x minus 2, x minus 4. X minus 2, x minus 4 is my quadratic trinomial that I've factorized correctly. Just looking for these two numbers. All right, number 3. X squared minus 5x minus 24. So they have to multiply, the two numbers have to multiply to negative 24 and they have to sum or add to -5. Now, you notice that my product, my multiplication, the two numbers have to multiply to a negative number. That means I'm looking for one positive and one negative. That's a clue. Has to be. Because the sum is also negative. Now, the factors of 24, there are many. So we need to kind of experiment. Okay, what's 12 and 2? All right, well, negative 12 times 2 is equal to 24, negative 24, that's fine. But if I did negative 12 plus 2, that's equal to negative 10. So, that's wrong. It's going to be a bit of checking. If you're unfamiliar with this technique, it might take a couple of goes. What else are factors? Well, 6 and 4, okay? So let's say I've got negative 6 plus, negative 6 times 4. Well, that's negative 24. That's good. Tick. Negative 6 plus 4 is equal to negative 2. Again, that's incorrect. Can't do that one. All right, what's another two factors? Well, 8 and 3. All right, let's try that. Negative 8 times 3 is equal to negative 24. Then negative 8 plus 3 is equal to negative 5. Oh, well, there we go. We found our two numbers. The two numbers are negative 8 and positive 3. So this expression here simply becomes x minus 8, x plus 3. And again, you can always check your own answers by re-expanding and seeing how you go. Using the FOIL method, do we get back to the original? If you do, then it must be correct. So we have that method. Now,